Hi, my name is John Jekyll. I am a Master's of Systems Engineering student at University of Arizona, and this is my project to use A-star in Python to solve the 8 puzzle game, which is a tile game that uses 9 puzzles with a missing piece in the middle, and you want to get them in a particular order. Many of them solved by going 1, 2, 3, 4, 5, 6, 7, 8 with a blank space at the end or some variation of that. But for this project, we had to make them in a circle, so it was 1, 2, 3, and then the numbers go around in a circle around the center, and the center is the missing tile. So here we're looking at the code for the main chunk of the program. Don't know don't recall the exact technical term in Python for the main, but it is the main function of the program. So it's the thing that everything is based on, and when this thing runs, this is what starts. And here, what you see is the main only opens up the an input file, which is a list of digits that are a list of 9 digits separated by commas that represent the initial state of each of the puzzles. These are 8 that I know that work so far, and the way that we execute this program is we go into terminal, and you execute python2 main.py, and it begins running, and that's right now all of those except for the last one are finished, and it's going to take a little bit of time for the last one because it takes over 20 steps for each of the different heuristic types. While that's running, we're going to go back here and look at how the different parts of the thing work. So main, after it imports the puzzles line by line and splits it into the data format that the program requires, it calls the A-star solution. There were this code that I found and that I've modified for this purpose. Originally used many different types of search methods, and I pretty much modified it just to use A-star in with 3 different heuristics. So what you're seeing here is A-star calls the A-star function and each of the different heuristics for the A-star. So here you're seeing A-star H1, which is displaced tiles, A-star 2, which is using the Manhattan and the Manhattan distance, and then the third one is using both Manhattan and displaced tiles both. So it calls up the search method. So this is A-star. This is actually executing the A-star algorithm. The solution, as you see here, you can define the solution state when you begin the game, and it will search for that pattern. And here you have the heuristics. So the heuristics, this is the heuristic for the displaced tiles. This is the heuristic for the Manhattan, and then this combines Manhattan and the displaced block heuristic into one combined heuristic. And I could probably do better with object-oriented programming by using more code than I did, but kind of pressed for time. So let's go back and see if this is finished. And it has. So we see that that it's finished with those 8 puzzle codes. So let's go and open up the so it exports the results into these three files here, which are out file heuristic 1, which is just displaced tile methodology, out file heuristic 2 is Manhattan, and out file heuristic 3 is the combination of those two. So I'm going to open this, and it's going to show the first puzzle and the steps it took to solve the puzzle, the number of steps it took for each one of the puzzles down here. And the minimum one took 2 steps to solve the puzzle. And the biggest one I have took 20 steps using the Manhattan